So without further ado, I'm going to introduce to you Oladayo, and he's going to be taking us through building a data analytics pipeline using Python and GCP for an oil surveillance dashboard. Oladayo, are you there?
Can you hear me?
Super, yeah.
Can you give me the permission to share my screen?
Please, go ahead.
You have to grant me permission. That's what I'm saying. Okay, I see that. Let me turn on my video also. Okay. Good evening, everyone. First of all, I would like to say a big thank you to Toby and John for the opportunity to present to this data community. So a brief intro of myself. My name is Oladayo Shinyonbola, and up until January, ending of January, early February this year, I worked as a petroleum engineer with one of the E&P company in Lagos. And since then, I've considered myself to be on a sort of a gap year in career while I'm learning different tools in data engineering, data analytics. So one of the major responsibility as a petroleum engineer is that you carry out production optimization. And by optimization means that you want to meet the target that the company has already set for you in terms of your production. So what that entails is you have to build an integrated model. Integrated models, you build models for your reservoir, you build models for your wells, and then you build models for your surface facilities. When you've done all of that, you can carry out optimization to meet your target. You know which well you want to give more gas lift to produce more, which one you should shut in, and the likes. So when you've done all of that, you start to observe what the wells are actually doing in terms of production. And that's where surveillance comes in. So basically, surveillance means you're monitoring what you've already forecasted for those wells to produce, and you're trying to see whether they actually meet what you forecasted. Now, you have to have a trend for you to be able to see what the wells are doing, and then you can go back to your model and let me use the word, maybe rejig it or reiterate it and re-optimize it based on what the wells are actually doing. The way we do the surveillance is we meet every week. Then I'll just collect all the data and plot it on Excel. But I always felt that there are better ways for us to automate the whole process. And that was what led to the project itself. Let me share my screen. So that's a little bit of the background to the project. I just felt that it was becoming too manual, too boring to just redo everything using Excel, collect data, and then plot, and then we discuss. And I felt that what if we could have a web app where everybody can go into and see the trend for each day. I also have to say that we don't have a real-time monitoring system, quite expensive. So the sort of data that we collect is sort of a batch data. It comes from the feed once every day in an Excel format. So that's the background to the project. So let me share my screen. Yeah, tell me if you can see my screen now.
I can see GCP.
Okay, so before I share my slides, I prepared like a 15 slides presentation because we're going to do some demo. So I really want us to start from the very scratch. So we're going to create a new project in GCP, and in GCP, your resources are organized in projects. So that means if I want to start a new project, maybe a new personal project, and I want to host it on GCP, it's better I start with a new project so that I know that all the resources for this particular project are hosted on this GCP project. That's what I'm trying to say. So we'll come here and then we'll create a new project. Okay. So it asks for your project name. So you can just give it a project name that you want. So I'll just say a demo production dashboard. And then location, I think that has to do with more of a corporate world. Some people try to segregate it into different organizations, different departments. But for this one, we just leave it as no organization. So we just create a new project. Yes, so it will try to create a new project. It's trying to create a new project. So let's just wait. Yes,
we're getting a comment here. Perhaps you could zoom into your
my screen.
Browser screen, yeah. So maybe you can Control Plus or something. I think that works. Yeah.
Okay. I don't know. Can you see it now? Okay.
Yeah,
so if,
thank
okay,
you.
so now if you look at the project, we have the new project that we just created, the demo production dashboard. So I'm just going to select that. And then you can go to the dashboard. Now, when you open the dashboard, you have the project information, you have the resources. Like I said, your resources are organized in projects. We have the BigQuery, we have SQL, we have the computer engine, storage, cloud function, and the app engine. So the very first thing I want to create here is a service account, because we'll be making use of the service account in the demo. What the service account API does is that it gives you a key, which is a JSON data type, and you can use it to connect from your IDE to your GCP directly. So I'm just going to come to this service account here and create one. So it says create service account. So we're just going to give it another name, demo production dashboard, and then we just create and continue. And then it asks that we should grant the service account some role. So what I do most times is that I grant it a owner and editor role. With the owner and editor role, that means I can create from my Python, I can edit, I can delete. So I give it a full access to the GCP. So I'll just come to the role here, basic, I give it owner. I add another role there, give it editor. So, and then I can say continue. So I've granted that particular service account, and then I create them. Now it's created that service account for us. But if you look at this place, it say no keys yet. So I'm going to create a key for it. Under this tab, you have keys. And then I'm going to add a key, create a new key. And then, like I said, it creates a JSON file for you. And then I'm going to create one. So right now, it's giving me a JSON key. I'm going to drag it here. And I'm going to take it into my demo folder where I decided to put all the resources for today. Copy it and paste. Okay, so we have it here. So like I said, you need a service account to be able to interact from your IDE, whether it's a Jupyter Notebook or you're using VS Code or PyCharm. Then let me go back. There is one more thing I want to create. That actually takes up to 25 minutes to create, and that's why I'm actually starting with it here, because I really want to demo it today. So one of the demos that we're going to be doing is that we're going to run our Python script or the OETL module on a Airflow, and you can use Airflow on Google Composer. So I'm going to create an Airflow environment in Google Composer. It's taking a while. Please just hang on. Okay, yeah. So it brought Composer out. So I'm just going to click on that. Sorry, I think my network is just, okay. So first of all, we have to enable the API. So we enable the Cloud Composer API. Yeah. It's asking me to enable billing. An account. Okay. So I'm going to select my billing account. Sorry that I'm taking you through this first, but I really want to demo it at some point in the presentation. So, and I really want to start it before the presentation. I really want to show people how to just go through the steps from the scratch, creating the project, creating all those resources one after the other.
Yeah, we're flowing along.
Okay.
Timidayo here is saying he didn't know that you can orchestrate Apache Airflow in GCP.
So yes, you can do that. And the advantage of doing it on GCP is that GCP takes care of all the infrastructure for you. You only just need to bring your Python code in and drop it in one of the buckets that is going to create for you. So it manages all the infrastructure. Another way you can do that is using Docker. And Docker takes a lot of your RAM. So sometimes it can be really slow. So what GCP does for you is that it just takes care of everything, all the infrastructure that you need to create. It just takes care of everything for you, for a cost. I'm really, it doesn't take this long. I don't know why it's doing this today. So I really think I should start the presentation. Hopefully this catches up. Time is running fast. So I'll just start with the presentation and then we'll come back to this. It's taking a while and I don't know why it's taking. So please let me go on with the presentation. I'll start with the presentation. So 15 slides. So can you see my PowerPoint? Can you see my PowerPoint?
No, I'm still stuck on the billing screen. And yes, please, whilst Oladayo is going through his presentation, if you have questions, write them in the comments. He's going to get to them. We're already seeing some questions, so please keep them coming. Oladayo, I can see your screen now.
Okay.
PowerPoint.
So let me go to this. Okay. Building an Oilfield production surveillance dashboard. That's the title of my presentation. So these are the agenda. Introduction. I'll talk about what production surveillance is, the building process, then we'll have the demo and then the conclusion. So introduction. So like I said, in simple terms, what production surveillance means is your monitoring changes in well parameters for wells in a producing oil field. In a producing oil field, you have many wells and you get a lot of data from those wells in terms of the rate that those wells are producing. You have a lot of sensors, pressure sensors, so you get a lot of pressure information. There are also things like a BS&W, GR. So the well parameters include, like I said, you have rate, oil, gas, and water from each well. So by rates, you're talking about the volume that each well produces in a 24 hours period for oil, gas, and water. Pressures, you have, like I said, you have sensors, you have at your bottom hole, you have at the surface. So you're measuring all of this also. Choke size, the best way I can describe a choke size is the same way you have same way you have a tap in your house and you increase it and you reduce it, a well has its own tap also, which is called a choke. So sometimes if you want to increase the rate of the at which the well is producing, you just increase the choke size. If you want to reduce it, you reduce the choke size. So think of it like a tap. Basic sediment and water. So you produce both oil and water, and they make up the liquid aspect of the production of the well. So what the basic sediment and water is talking about is what proportion of does the water the best way to describe it is the proportion of water in the liquid. So you have oil and water making up the liquid. So you're looking at the proportion of water in the liquid. So it could tell you when it's going higher and higher that you're turning into like a water producing company, because that's what the well is producing more. And then your GOR is your gas oil ratio. You're looking at the ratio of your gas to your oil. If it's going higher and higher also, it tells you that you're producing more gas than water. And if the feed is actually meant to, the main target of the feed is oil production, that means you are wasting a lot of gas and you might want to bring down. Also, parameters also include uptime. How many hours in a day is your well online for? So you monitor that also, because that could also affect what the well produces in a 24-hour period. Now, why do we do all this production surveillance? Now, the first thing is you do that because you want to identify anomalous data. So when you create a trend for all your parameters, if there is a sudden change in your trend, you want to inquire whether there was an issue or whether it's an anomalous data or from the feed. So, and then the second reason why you do that is you want to see how the changes in one of the parameters affect the parameter of most interest, which is your oil, because at the end of the day, is your oil that you sell and you make money from. Now, so the background, like I said, I decided to automate the process because it's becoming so boring, rejigging the whole data every week and creating a new plot on Excel. So starting out, I created define the requirement for this project. Now, the first is I said the data needs to be dynamically updated on the dashboard. What I mean by that is when a new data comes in, with little or no effort, the dashboard should update itself with the new data that came in. The dashboard can answer some common questions always asked. So one of the common questions I always get is, Oladayo, what did this well produce within this period to this period? Or what's the average production within this period to this period? So I wanted the dashboard could do that also to answer some common questions. And then the web framework for the dashboard needs to be deployed. Now, the reason for this is even if you build your dashboard and you can't deploy it, that means it's only local to your own system. You can share it with others. So everybody can just have the address, the web address, and they can go to it and look at what is happening. So those were the 3 requirements I defined for the building of the dashboard. Now, the first iteration, this is the architectural diagram. So I have a folder on my system, and then I wrote a Python script, and it created a dashboard. Now, what I did with the folder is I decided to take 3 months of data, that's like 92 daily reports, and keep it inside a folder on my computer. I wrote a Python script that interacted with the folder. Interacted with the folder, extracted all the data that is needed and transformed it. And then inside that same Python script, I created the dashboard. Now I have to say that the package that I used for creating the dashboard is not the normal no-code Tableau or Power BI. I use Plotly and Dash. So Plotly is one of the data visualization package, just like you have Matplotlib on Python. So you can use it to create your visualization. Dash, you can now use Dash to create your web framework. In using Dash, you have to know a little bit of HTML, a little bit of CSS. So you're moving into a little bit of web development. So that was what I used, but it was a mess because on the same Python script, I had the extract script, transform, and then I had all the code for the Dash and Plotly, and then it created a dashboard, this dashboard. Now, I'll take a pause from this. I want to show you a video of what the first dashboard looks like. I've tried to look out for the script, but I can't really find it again. But I actually created a video for what the first dashboard looks like so that everybody can see what the output of the first looks like. So I'm going to play a video. Okay, let me reshare the screen to this place. Okay, tell me if you can see the screen.
Yep, I can see the line chart.
Okay, so this was how the first dashboard looks like. And if you look at the address here, it's a local address. It's great. So, and you can see the title here, Dash. So it's a local address. I just had the title, production surveillance dashboard, select the well and select the well property. And then I had this line chart all over the place. To be honest, when I created this, I was super happy because this was my first time using Python on a project. And I was like, well, I mean, you did something. I did the backend also in the interactivity and the callbacks. And that's what is leading to anytime you change the drop down input, the output, which is the chart here, keeps changing. So let's just play to the end. This was what the first dashboard looks like. Yeah, so thank you for that. Share screen. And then let me go back to the presentation again. Now, what are the limitations of the first one, of the first iteration? Now, I had to manually run the script each time I added a new daily folder. Remember, one of the things that I set out is that it has to dynamically update itself. So anytime I put a new daily report into the folder, I have to run the script all over again so that it could update the data. Also, the dashboard output only runs locally on my computer, so it hasn't still met my requirement that I have to be able to deploy it so that I can share it. And then obviously I can sure do better with the dashboard output in terms of the layout and presentation of the visuals. So those were the limitations of the first one, of the first iteration. So that now led me to the second iteration. But let me come back. So the first two limitations here were solved by GCP. So I went into the rabbit hole of learning what GCP entails, and I discovered that I could solve the first two limitations with GCP. And then in the third one, I started learning about another package in Dash called Dash Bootstrap Components. What that Dash Bootstrap component helps you to do is that it helps your layout. You are able to arrange your visuals in rows and columns. So that helps you to arrange your visuals very well. Now look at what the second iteration does. Now we have a Google Cloud Storage bucket here. The best way to think of a Google Cloud Storage bucket is a folder on your local computer that is hosted in cloud. The same way you have a folder on your system whereby you can put any kind of files there, that's what your bucket is on GCP. You can put any object in there. So what I did was that I moved all the daily reports from my local system, my local folder. I moved all of them into a bucket on Google Cloud Storage. Now, there is the Google Cloud function. Remember, the initial script that I wrote in the first iteration had both the one that extract the data, transform it, and then the dashboard, the visualization and the dashboard. So at this point, I separated it. There is the one for extracting the data, transforming it, one, and then the second one for the creation of the dashboard. So what I did was that I deployed the first one, which is for extracting data and cleaning it and transforming it. I deployed it to a Google Cloud function.
I think we lost Oladayo there. Yep, so let's just wait a second and have him rejoin. And we're seeing a lot of questions in the comments. Engineering or analytics engineering has been quite the buzz. I really hope people are treating it not as a buzz, but as an avenue to add to your current skills. Still waiting. Okay, I think.
I'm so sorry, my network just went off. I've been having network issues all day.
It's all right.
Okay, so I'm just going to go back to the presentation. Oh, okay. Okay, so let me just recap. So the Google Cloud Storage is just like a folder on your local computer that is hosted in cloud. You can put any kind of object there, whether it's an Excel file, a CSV file, or even your audio or your images, you can use it there. Then, like I said, Google Cloud Function is one of your compute service that GCP has, and you can use it to deploy your Python script. And what it does is that it only runs in relation to an event happening. It doesn't run 24/7. It only runs in relation to an event happening. And what they call those events are triggers. So one of the triggers that it offers is that anytime I can set a trigger that anytime a new daily report or a new file comes into this bucket, this function should run. So that makes it the best compute service to actually use to deploy. That is what I want. I just want to be able to pick up new data, put it inside the bucket, and then the Google Cloud Function triggers and run immediately. So that makes Google Cloud Function the best. Another trigger is the HTTP trigger. So it generates an HTTP for you. And anytime you run the HTTP, it runs the script here. Now, that leads into another Google Cloud Storage bucket. So what I did was that after this runs finished, it generates a data frame. And in Python, a data frame is just a two-dimensional data structure. Your data are arranged in rows and columns, and it stores it back into another bucket that I created as an Excel file. Now, the difference between the Excel file here and this here is that here I have all the daily report that comes from the feed here, loaded here. But here I have just a single Excel file that contains all the data from all the daily reports here in an Excel file in rows and columns. So it's well arranged. And then I took the second script, because I told you that initially we had two scripts, the one that does the cleaning, extract cleaning, and then the one that does the dashboard. So I brought the second one and deployed it to the Google App Engine. Like I said, the Google App Engine is also one of the compute service. And what it does is that it helps you deploy your web applications in GCP. It's called Platform as a Service. The equivalent one that it's quite popular is Heroku. I don't know if you guys have heard about Heroku. Yeah, it's also Platform as a Service. So it makes the deployment so easy where you don't have to worry about the infrastructure at all. Also, the Google Cloud Function, the equivalent of Google Cloud Function in AWS is the Amazon AWS Lambda. I'm sure some of you have AWS Lambda. That's the function as a service in AWS. And for Google Cloud Storage, you have the simple storage service in AWS. That's the S3. So those are the equivalents if you're using a different cloud provider. And with that, I'm able to generate a new dashboard. Now, I'm going to show you what the second iteration brought in terms of the outputs. So I'm going to reshare my screen. Okay. Now, this now gave me, remember in the first iteration, we just have an address that is local to my computer, but this gave me a web address after I deployed it to the Google App Engine, and then we can look at how it looks like. Now, so this is what it brought anytime you load the address. This is how it looks like. Now we can see the title, which is the production surveillance dashboard. You also get the last update. So it tells you that the last report that is being that's been updated is for 29th September 2021. Oh, sorry, let me say something. All the data that I'm showing here, I've already had dummy data, not the real company's data. These are dummy data. I've actually changed all the data to a dummy one. So you have your drop down, you have your well, it's asked that you select a well, and then you select the well property, rates and cumulative, and then you also have a date ranger, which is from your start date to your end date. Now, the next thing you see here is you see uptime. So this tells us that for this particular well, the uptime is 24 hours. Let me zoom in first. Yeah, can you see it?
Yep.
Okay, so it tells you that, okay, the well was online for 24 hours for that particular day. And then, like I said, your choke size is like your tap. Most of our wells have a 192 inches choke. So this well was only open for 56 inches out of the 192 that it could be open to. That's why the bar only shows it up to an extent and it's not the full extent. Then we now come to the line chart. And then you have your oil from where I started from June 1st to September 29th. This is the trend for this particular well in terms of the oil production. This is the trend for the gas. This is the trend for the water, and this is the trend for the cumulative production. By cumulative production means what's the total production of that particular well throughout its lifetime since the first time it produces up to this moment. So it shows how the trend is increasing. You also see the oil production for that day, which is 7,959, 7.58 for the gas, 2 barrels of water per day. And then this is the cumulative production in terms of volume. Now, the choices for the column, it's just to follow the notation in the oil and gas industry. We use green for oil, we use red for gas, we use blue for water, and we use green for oil also. So that was very easy in terms of choosing the color that I actually want to use. Now we could go again. These are the rates and cumulative. We could go to, sorry, there is a little bit of high latency in terms of the interactivity, but it should work. Okay, so I selected another well properties. You have the BS and W, like I said, and then you have your GOR. It shows you the trend for those ones also. And let me go to pressures. And then you see the trend for the pressure. We use red for pressure. So you have the reservoir pressure, you have the bottom of pressure, you have the surface pressure, and then you have the drawdown. These are different pressures that we measure in the well. So it shows the trend for that also. Then I could go to other wells also. Let me go to other wells. Okay, it's changing, but I don't know if you guys are seeing it. Let me select another well. Okay, it's changing. So what I'll do, so that with this time, I'm going to put this inside. That's all. Sorry, let me go back to the rates and cumulative. Okay, so you could also select a range of dates here. So I started from like June, and then I could see what's happening to maybe just August. So it's updated. So when you select a range of period, it tells you what the average uptime of the well has been within that period. Not really the average choke size. No one looks at the average choke size. It only tells you the choke size for that particular, the end date here. And then look at the average oil production, average gas production, 1362 for average water production. And then it tells you how much the well produces within that period. These are a lot of questions that I do get. Oh, that what's the average production within this period? What has this well produced within this period? And this sort of solved those problems for me. So like I said, I'll go to the chat box and put the link there so that everyone can actually just, sorry, I think there is an error there. Okay, so yeah, I put the link in the chat box. Everyone can visit it and see how it looks like. So this was what the second iteration brought out. So what I've done differently for the second iteration is that I've moved some of the resources to cloud, and I've actually used what they call the Dash Bootstrap component to help me lay out these different components. Like I've had to use, okay, so what Dash Bootstrap components does is that this particular one is a row there, then this is another row. This is a row, this is a row, this is a row, this is another row. So I'm using rows to arrange all the components of the web application. Then when I get to this point, this is a row, but I divide the column into two. This is the first column for this row. This is the second column for this particular row. Then move to the next row. This is the first column here for this second row, and this is the second column for the second row here. And it makes it very easy for you to do. So I'm going to go back to the presentation. Okay, so yeah, that was what I did in the second iteration, and that was the output that we have. So a little bit of the cloud function metrics. So after I've already done that, I needed to be sure that when I put the new set of daily reports that are coming from the feed, it will run as I expect. So I took fresh new, like a 30 new daily reports, and I started uploading it into that initial bucket. That's the first bucket. So what you can see in this metrics is just focus on this part only, the invocation here. Now, if you look at this place, there is a spike here. So that means the Google Cloud function that I deployed actually ran. If you look at the trend here, it says, okay. So I put the first daily report here, it ran very well. And then it went back to the axis. The trend went back to the axis. I put the second one here, it spiked up again, and I did a third one, and then it went back. And then that's 3. And then I put 27 daily reports at a time. And then that's why you see this big spike. Yeah, and then it goes back after it's run. So you can monitor your Google Cloud function through the metrics and see the spikes here. And then you can look at this place. It says, okay, that means it ran. There was no crash or anything. I should also say that your Google Cloud function only charges you when it runs. So all through this time that it's at the state of rest, I'm not being charged. It only charges you when there is a spike here, a spike here, a spike here, a spike here, only when it runs. Now, also, immediately it's updated to the new data. The Google App Engine, where I deploy the web app, also it automatically updates itself. So one of the things with resources on Google Cloud is that they are scalable. Immediately changes happen to something, they pick up the changes quickly and then they update it. And that's what the App Engine does for you. So I just wanted to show you what the metrics look like here. Now, again, there are some limitations to the second iteration also. Now, what are the limitations? I said every time the Python script runs as a result of a new daily report added to the first Google Cloud Storage bucket, it creates the entire files in the bucket all over again. So let's assume that we have a 90 new daily report there. Everything has been read, the dashboard is working. By the time I put the 91st report inside the cloud bucket, it runs everything all over again. I mean, it's not an issue, but the problem is that there is a timeout for your Google Cloud function. It's 9 minutes. If it doesn't run within the 9 minutes, it fails and then it retries again. So what that means is that if I keep adding and keep adding, the runtime for the Google Cloud function keeps increasing because it's have to read more and more report than previously. So at some point, it might fail because there is a lot of report to be read. So that's one of the limitations for that. It would have been nice if it can only read just the new daily reports and then it appends it to the other data frame that has been created, and then it updates itself instead of reading everything all over again. So that's one of the limitations. And then I stored the transform data as an Excel file in my second Google Cloud Storage. What that means is that that data cannot be queried. for analysis. You cannot use an SQL to query it. That's a limitation also for me. And then another limitation is that while the dashboard output works very fine for additional data from subsequent daily reports, it will capture the data from an entirely new well. Now we have 12 wells here. Let's assume that a 13th well is brought online. And then in our daily report, they include a 13th well there. It will capture the 13th well. And the reason being that for me, the way that I started the data was that I had to use integer location indexing in Python. That's iloc. So when you use that, you've already specified to read between this place and this place. When a new one comes in, it will only read those places. Also, it won't look at the the additional one. So that's an issue for me. So one thing that it has told me is that when you're talking about scale in data, it's multidimensional. Your scale can mean that, okay, it works for the same data, but a new one, for the same data from the 12 wells. But what if you have a new well brought online and then it's 13th well? That's an entirely new data from a new well. It won't work. So sometimes when you're designing your pipeline, you want to be able to capture, if it's the same data that you've built the pipeline for, it should be able to accept new ones. And then if an entirely new data comes in from maybe a new well, it should be able to capture that also. You want that sort of things to happen to your data pipeline also. So you want to build it to be multidimensional in terms of scale. So what's the update? So this is the new update. You have a Google Cloud Storage bucket, like I said, where we put all the daily reports. And then you have the Google Cloud function. But instead of having it as Excel file, you're now taking it to Google BigQuery, Google Cloud BigQuery. So what's the BigQuery? BigQuery is a data warehouse in GCP. Now, what is a data warehouse? A data warehouse is where you store data, but it also has an inbuilt engine, inbuilt query engine. That means you can carry out an SQL on the data that you store there. So yes, so I changed this to BigQuery, and then the Google App Engine reads data from the BigQuery, and then you have a dashboard there. So nothing has really changed except for the middle point in this architectural diagram, whereby I've already replaced that. Instead of being a Excel file in Google Cloud Storage, I'm actually using Google BigQuery. Yeah. So we can now move to the demo. Now, we're going to do 3 demos. For the first demo, we're going to read data from a Google Cloud Storage bucket. We're going to use a Python script, and it's going to deliver the data into a BigQuery table. That's the first demo that we're going to do. For the second one, instead of us running the Python script on our own, we're going to move those Python script into a Google Cloud function, and we are going to run it, and then we're going to look at the data here. And the third one, that's why I was trying to create a Google Cloud Composer. We're going to use Airflow to orchestrate this entire workflow. So let me talk a little bit about Airflow. It's an open source tool that you can use to orchestrate your workflow. You can use it to run it, you can use it to schedule it, and you can use it to monitor it. It's open source. It was developed by Airbnb engineers, but they made it open source on Apache community, for Apache community, so everybody can have access to it. So that was what I was actually trying to create a Google Cloud Composer. So let's go to the first demo, but I forgot something. I've also made a little bit of change to the Python script that was deployed here. Instead of it running all the old files from the beginning, it now reads only the new file in the bucket. So I've made a change to that also, and we're going to see it in the demo. So yeah, let me escape this. Let me go back to this. So I'm having issue trying to enable the Google Cloud Composer here. So what I'll do is that we're going to use one of the projects that I've actually created, which I've already enabled billing. So we're going to use the dummy surveillance project. Okay, so I can go back to the dashboard. So first thing first, we're going to create a buckets in Google Cloud Storage. So if you look at the resources here, there's a storage resource here. Let me zoom in. So you can be seeing. Can you see it?
Seeing your presentation in PowerPoint.
Yeah. Okay, sorry. I'm coming. Stop share. New share. Okay. You should be able to see it now.
Yep.
So it's taking a while for the new project to work. So I'm just going to work with an already existing project, but we're going to create everything from scratch. So first thing first, if you look at, I've gone to the dashboard of GCP. If you look at here, you have resources here. And we want to create a bucket. So you come to the storage here and just create storage. So I've already created a lot of buckets here. So I'm just going to create a new bucket. Now it asks you to name your bucket. So we're just going to say demo bucket. Now this name has to be unique. So it tells me it has to be globally unique. That means someone has already used this name before. The bucket is taken, so we have to try another one. So let me use demo bucket. Okay, let me just add the report there. I hope it's not taken. Okay, this is not taken, so we can continue. Now this place, it asks you to select a location type. Now GCP has a location. So basically it's asking me, where do I want this data to be stored? They have a lot of data centers, a lot of location, but so I could actually choose a location where I want this data that I'm going to upload there on the bucket, where it should be stored, which of the data centers or locations should it be stored. So you can choose multi-region, or you can choose maybe just a single region. So for this, I'm just going to choose just a single region. And you can choose any region that you like, but I'm going to choose Europe West to London. That's where the data should be stored. Then I'm going to continue. Now it's asking you to choose a storage class for your data. I'll just go with the default, which is the standard, but let me just quickly say something about the class. So if it's a bucket that you will be accessing frequently, you want to use a standard one. If it's one that you'll be doing once a month, you want to use Nearline. If it's one that you want to use maybe once every quarter, access it once every quarter, use the code line. If it's once a year, you want to use archive. Apart from that, the cost of the standard is a little bit higher than the Nearline, code line, and archive. So in terms of cost consideration, you could use standard if it's something you want to be using. But if it's not something you want to use for long, just use archive. They charge you less for archive compared to standard. So from cost perspective, that's it. So I'm going to continue. This is asking for some security. Enforce public access prevention on this bucket. Yes, I don't want anybody to have access to this bucket, only me. So I just leave it the way it is. Then choose how to project object. If you want to be able to recover your data, or retention policy, if you want to be deleting it after a certain period, if you want the data to be deleted after maybe 30 days, you could use of this object versioning and retention policy for that, but I'll just leave it as none. And then I'm going to create the bucket. So confirm. Again, it's showing us that the location is this, and then I'm going to be charged this particular cost. So it has created the bucket for us. And the next thing you want to do is that you want to upload your files there. So I'm going to upload the file, which is the dummy report that I've created. So I'm going to go to my demo. I've created the demo daily report, and I'm going to just upload just the first one there. Okay, sorry, my network it's quite slow, but can we see it has already uploaded the daily report inside the bucket. This is it here. So now I have that set there. Now also, we are ingesting this data, the clean data, into a BigQuery. So I want to go to BigQuery and create a table inside BigQuery. So I'm just going to go back to the resource, the dashboard. So you see here, we have a BigQuery here. So I'm just going to select the BigQuery. So this is how the BigQuery looks like. So I already have my project name, which is Dummy Surveillance Project here. So I'm just going to expand it. The next thing I want to do is I'm going to create a data set first. And then it asks me for a data set. So let's just say ingest, let's say ingest data. Hopefully it allows me. Ooh, okay. Try underscore. Okay. So yeah, data location, if you wish, you could also select London, enable data table expiry. So if you want your table to expire after a certain number of days, you can actually enable it. So if I enable it, it will ask me for the number of days. So, but I'm not doing that. So I'm just going to create a data set. Now, if you look at this place, it has created a data set, ingest data. Now, the next thing is that you want to create a table. Now we're creating an empty table, but you have the option of creating a table from Google Cloud Storage. You can upload your own table also, upload from Google Drive, Bigtable, S3, or the Azure Blob Storage. You can ingest data from there, but we are doing an empty table. This is our project name. This is our data set name, and we're going to call this production data table. Now it's asking us for the table type. It's just a native table. Now it's asking us about schema. I'm going to enable this edit as test. I'm going to describe the schema that I actually want in this table. So I'm going to enable this. Now it's asking us, we have to put a test here. So let me, oh no, sorry. So what schema is, you're going to define your column for the table, and you're going to state what type of data type each column is. So just give me a minute. I'm trying to copy. I have it ready so that we don't. Okay. Okay. So here we go. Now, let me close this. Okay, so can you see what I put there? So in the schema, so what I've actually put here, it's a JSON data type. You have a list, then you start defining the dictionary. Each dictionary is a column. You specify the name, which is date, and what's the type of the data. It's a date type. The wells, and then the type is string. Then we talk about the choke size, and then the type is integer. The uptime is, and then it's float. The THP is float, the BHP is float, the P star is float, the DP is float, oil, integer, gas, float, water, integer, BS and W, float, GOR is float, and then the last one is cumulative production. So I'm going to take this one out, and just name this as BS and W. So with that, I've already defined the schema. Like I said, the schema is just defining your columns names and the data type for that column. And partitioning and cluster. For those that do SQL, you do partitioning sometimes and clustering. If you want to do that, you can enable that, but we're not going to do partitioning here. So I'm just going to say create a table. So it tells us that production data table has been created. So we see that the production data table has been created. So what you see here is you see all the feed name, which we defined in the schema, date was, and all of that, and the type it is. And then it tells us the mode, null label. That means the column can actually take in null data, empty data into them. So that's what this means. If you go to preview, oh, sorry. Oh no, this is the previous one. So I should be looking at the ingest data, sorry. So we shouldn't have any data there. So we have all the feed and then the type. If we go to preview, it tells us there's no data to display. So there's no data in our table, yes. And then I also said something about BigQuery. BigQuery helps you to store your data, and it also enables query. It has an inbuilt query engine. So you see the query here, you could just say query in new tab. And then it gives us an SQL command already. I could just say select star and then run. Can you see there's no data to display? It ran, but there's no data to display. So we've created a storage bucket and we've created a BigQuery. Now the next thing is that we need to ingest data using Python to this data table. So I'm going to open my, just give me a minute. CD. I'm going to open my Jupyter Notebook. Okay, let me reshare my screen. New share. Okay. Okay, can you see my Git bash stuff?
Yep.
Okay, so I'm just going to, I'm going to initiate a Jupyter Notebook in this folder. I tried to initiate Jupyter Notebook from Git bash. I don't like going through Anaconda, launching Anaconda, because it's, when I try to exit it, it takes a while and I have to force it close, but I can go through Git bash and open it without opening Anaconda, and then I can easily shut it off when I'm done. Okay, so I've launched it and new share. Okay. So can you see the screen now?
Yes, but you might have to zoom in.
Okay, let me open this one first. Sorry, I'm trying to open the Python script so that we can go through it together. Why is this slow? Okay. Okay, so can you guys see my Jupyter Notebook, the notebook here? I'm trying to zoom.
Yes.
Okay, so let me restart this. So this, I called it the demo script. So first of all, you have all your packages that you need. So I imported all this package here. So the first cell is just for all the packages that I need to say, I'm going to load it. Now, the next cell, I call it, it's a function, and I call it latest file. So what this function is supposed to do is that it's supposed to get the latest file inside that bucket that we created. just get the name for us. So we're going to do some editing here because this was the script that I used for a previous bucket. First thing first, we have to define an environment, our Google application credentials. You remember when I started, I downloaded a service account. So this is where the service account comes in play because it's what will give us the chance to be able to connect to that bucket. Okay. So what I want to do is inside my demo file, we're going to use the previous bucket, the previous service account that I've created, not the new one, because we're using in different projects here now. So just give me a minute. I actually wanted us to do it from scratch, but my network failed me. Okay, let me go back to, can you still see my screen?
More like the background, the wallpaper. I think we can, nope, can't hear you.
Can you hear me now?
Yes. Now
yeah, there was actually a freeze at some point. So what I said is, since we're using an old project that I already created, we have to use that service account for that project and not the new one that we created. So I've already gotten that service account, and I'm going to just replace this one. Okay, so yeah, I've done that. Now the storage client means that it has to go to the storage resources. Now I put a previous here. Our daily report has the name daily production report. So I just put a previous here. And this one is just like a extra security. Sometimes you can have maybe someone mistakenly upload a file that shouldn't be there. It will only look for files that has this prefix daily production report. That's why I put it there. It won't look for any other files that bears another name. And then it's read this bucket. Now this bucket was the one that I created before. So we're going to change it to the name of the new bucket that we created. So let me get the name.
Hey, Oladayo, seeing as we're
Yes.
running out of time, I'm thinking you show us this flow, and yeah, we take some questions and we wrap.
Okay, just let me just demo just this particular one. I'll try to estimate maybe in the next 35 minutes we'll be done with this.
Yeah, we have some interesting questions here as well. People are very interested in learning more about this. So yeah.
So the name of our bucket, the name of our bucket is demo bucket report. So okay, let me just run the script so that we see. So I'm just going to run this one. Latest function. Okay, so now, like I said, this particular script, it just returns the latest file in that bucket, and then I've called in the function. Can you see the outputs? It tells us that it's the daily production report 2021-06-01, which is the same thing that we uploaded in this bucket. Yes, so that does that. We've gotten the latest file. Then the next thing is that we want to read that file. It's just your PD pandax. You read it. Let me call that function also so that we can start seeing. So this is how our daily report comes in from the feed. It's messy. a lot of merge cells, a lot of stuff, but you can see it. We have 461 rows by 29 columns. So this is how it comes. It's from the feed. Now, I call this one extract date and well data. So I'm just going to run it. So it extract the date and well data from this data frame from the file that we just read. And then it returns the date list and the well list. Then the next thing is that I want to claim the date. If I may, sorry, let me run the function so that we can at least see what the output is. You guys will probably allow me to come back to come and demo the remaining at some other point. Can you still hear me?
Yep.
Okay, so look at what the date list returns. It returns 2nd of June, 2021 at 8:00 a.m. This is what it returns. We have 12 of it in a list because we have 12 of us. Then if we do for the well list, let's see what it returns. This is what the well list returns. We have the different wells. This is what it returns from the data frame. We've not even done any cleanup. We've just extract those data out. Now, if we move to the next one, we'll start doing the cleaning. Now, I do the date cleaning. And look at what the date looks like now. Initially, this was what we had. Sorry, I've already taken it out. We had something 2nd of June, 8:00 a.m. But this is what it looks like now. We've already cleaned it and turned it into a data frame with the column dates. Then we clean the well also. And then we can see how it looks like. Now we have this. We have the well name, even though the columns are unnamed, but we have something that is far cleaner than what we had here. Then we move again. So after cleaning it, I brought both the date data together and the well data together. So let's see how that looks now. And then I make sure that the data type are in their, the data in their right data type, whether it's integer or float, or also those ones that needs to be in updated wells. Oh, sorry, I've not run this. While that is coming up, the next thing was that I defined the initial, okay, see how it looks like now. We now have the date, we have the wells, we have the choke size for that particular day, the uptime, and all the data that we needed. Now, the next one is, I won't really dwell so much on this, the initial cumulative production. You know, I'm not starting from the scratch. I only started from like 1st of June. Those ones have actually produced a lot till like maybe 31st of May. So I got the production, the cumulative production for those wells as at 31st of May and defined the cumulative production. Yeah. So that's just a dictionary. Now, at this point, I had to read the BigQuery table. You know, we've created a BigQuery before, a BigQuery table before. So please, I'll just come to this place and copy this service account because we need it to access BigQuery. So all of these are going to be replaced. Yes, we've replaced that. Now, we're trying to read our table in BigQuery. Remember, there's really nothing in that BigQuery table. So I'm going to go back to BigQuery table and copy Can I remember the name? Yes, we name it production table, and I call this ingest data. Let me ingest data. Hopefully it works. So I named the client that, okay, it's BigQuery that I really want to access in my GCP. And then I query the string, read everything that is inside the table for me and convert it into a data frame. So I'm just going to run this. And then let's see, let's call it. Let's call the function. Okay, can you see what it did? It gave me all the column names that we've defined in our BigQuery, but there is really no data there. So it just listed the columns names. The reason why I did that was that depending on whether data is in our BigQuery table, that is how we're going to decide how to calculate the final data frame here. Because the cumulative production, we have to calculate it. So now look at this. I defined the final well data, and I was like, if it reads the BigQuery data and then it checks for wells and there is nothing there, if it's an empty list, it should do this. It should execute this particular script here. But if there are data there, it should check whether the date that we've created for this, our new data, whether it's not in those BigQuery, so that we are not doing repetition there. And then if it's not there, it does this. But if it's there, it does this. Because I also know that sometimes your report can come from the field and there are errors there. And then you make some changes there and you reload it there. It's still the same data and it will see the previous data that is there. So it's just going to change all of this. So let me just run this particular cell and see what we have. Final well data. So let me call it. Okay. Yeah, it's taking a little bit of time to return. Okay, now can you see the difference now? We've now had the cumulative production to our data frame. So we finally have what we need. So we have this data frame and then it's ready for ingestion into the BigQuery table. So before you ingest it, you have to also define the table schema. Remember that we defined the table schema when we're creating the BigQuery table. Exactly the same thing that we did is what we've defined here. So it has to match what you created before. So I'll just run it. Exactly the same thing, I'll just run it. And then the final thing is save to BigQuery table. Now, the first one is, if it's the first time we are ingesting into it, it should just take this data frame and take it into this production data set, which will have changed to ingest data. And if it exists, I said it should just append, but we don't expect anything to be there. So I just put a 10, and then I define the table schema to be this, and then the project ID is this. Now, what if we have data there and it's a new data that is coming in? It checks for it, and then it just appends also. But what if it's a data that has already been ingested and we made some changes? I said it should just replace. So I will run this. And the final thing that I'll do is that I'll save to BigQuery table. So I'll call this function and we'll see what happens there. Well, it worked, but I also have made changes to this name also. This is the one that will work, this first one, because there's really no data there. So I should have changed this production data set to ingest data. Sorry, we're almost rounding up on this. Maybe another time, you guys give me another time to use Google Cloud Function and the Apache Airflow. I would have loved to really demo the Apache Airflow. Yes, so by the time you see this particular bar, which says 100%, that shows you that it has already ingested. So we can go back to our BigQuery table and go to the dashboard and go to BigQuery. Okay. So we come to the project. We'll come to our data set, which is just data, and then we see the production table. Now, if you look at this, we have the schema, we have the details, and then we can preview it. By that time, we have our table here, stored here. And then you could, carry out select, and then you can run your SQL commands, a simple one. And then you can have all of these. It's still just select star from that, and then you can have all of this. So that's how we ingest table using our Python script from a Google Cloud Storage into a BigQuery. I should mention that many of you would have heard something called ETL, ELT, the extract, transform, and load. One thing I've realized from seeing what other people have done is when you're loading, they're always loaded into a data warehouse, whether it's a BigQuery table or the Amazon Redshift. So this is the best way to go, because sometimes also you might want to do some analysis with your SQL, select star from a well, what's the sum of the oil production within this period. You could carry out those analyses using SQL. So it's best if you are ingesting your transformed data into a data warehouse rather than saving it as an Excel file. So this is better. So yeah, that's how to ingest the data from a Google Cloud Storage to a BigQuery. So that's exactly our demo one. I hope you guys give me time next time. We will use a Google Cloud function. We would also try to use Apache Airflow. And thank you for listening to me.
Fantastic. Fantastic. I honestly, like, if we weren't short of time, this would be very, very wonderful for people to catch up on, right? The entire process of building. In light of time, I think everybody is really, really interested in picking this forward, as you can see. And if we can take a few questions, right? Because we're well over our meeting time, I would say, how, like, which of these platforms would you advise someone to get into, or which framework, if someone is willing to learn data engineering? Should they go for Azure or AWS or GCP? How and which other additional tools should they look to learn?
Okay, before I answer that question, I just dropped the link inside the chat box. I would want everybody to try and load that link. That link, it's a function that I deployed, but instead of using cloud storage, I use HTTP function. So anytime you guys run it, you guys would have run that script that is in that project. You would have run it, and the output would be the function ran successfully. So I dropped the link there. You guys can try it. You would have triggered that script to run. Okay, so to your question, I don't know whether I'm the best person to suggest what sort of cloud tool to use. But when I started, I actually started with AWS, but I didn't find it easy. It looks too difficult for me. So I went to GCP, and I think GCP has a good documentation. So you could easily follow the documentation, and you could easily learn from. If you're starting from scratch, you can easily learn fast with GCP compared to AWS. I've never tried Azure, but I think GCP is quite easy to learn to me, and it has great documentation also. But I also know that from people that I've interacted with, most companies tend to use AWS. So it won't be bad if you also try to learn AWS on the side. And that's why you see that anytime I'm mentioning a resource on GCP, I'm also telling you the equivalent of it on AWS. So because I still have plans to, at some point, dive into AWS also. So it will be, some companies even use multi-cloud. There's something called multi-cloud. So by multi-cloud means that they use AWS, they use GCP, and they probably use Azure. So they try to use some resources for GCP, they try to use some resources for AWS. And like you see when we're trying to create our data, the table in BigQuery, it also allows you to interact between GCP and AWS also. You could load data from S3 into GCP. So I would advise that if you can learn both, it's fine. But if you want to start with and you don't want to get demotivated from the scratch, start with GCP, and then you can now move into AWS. And also, GCP offers you like a $300 credit when you start, so you don't have to pay for anything when you start for like the first 3 months. You don't have to pay for anything. I think Amazon does also, but I'm very sure of GCP. They gives you 300 units of credit. That's $300.
Yeah, I also found the experience like similar. It's much easier to get started on GCP. There's a sandbox you can create with pretty much your Gmail address. It's not complicated.
Exactly. And talking about other tools, if you're delving into data engineering, okay, I should say that the main role or main responsibilities of a data engineer is to build data pipelines. You want to be able to do something like this that we've done, where you extract data, whether it's from a CSV, Excel, or an API or logs. You should be able to ingest those data, clean it, and send it to a data warehouse where the people that are using it for analytics will pick it up from, or where people that are going to do some machine learning are going to pick it up from. There are also something they call reverse ETL. So when you've already cleaned it and you have it on your data warehouse, you can be feeding it back into the source where you got the initial data from that you transformed. And I think that has to do with when you're dealing with people that are building platforms, like maybe a fintech platform. Sometimes they need some clean data that they generated to return back to them. So they call it reverse ETL. But people believe that this is a traditional way of doing things now, ETL. But there's also another one called ELT. So
I think there's a lot going on around, those
yes. So what happens there is that when you extract the data, you're not doing any transformation. You're just sending it to the data warehouse. So you extract and you load it to the data warehouse. The transformation will happen with what one of the two calls DBT. Yeah, that's where DBT comes in to help you do the transformation. And what you use there is just SQL to do the transformation. But I learned that they are trying to make DBT use Python also in DBT also. They're trying to enable Python in DBT also. But for now, you can use SQL. And that's why it has created a new role in data ecosystem called the analytics engineer. The analytics engineer just picks up the data from the warehouse and build those models for you, transform it, and the analyst picks it up from it, the machine learning picks it up from, engineer picks it up from. So yeah, I would recommend to learn DBT. And they have a fantastic course on their website. It's quite free and you get a certificate for it. It's just the fundamentals. It's very interesting. Trust me, it's very interesting. And the only thing
sorry to cut you short, but there's so much that we have to cover. And I'm thinking maybe we take the final question, which a lot of people are asking. It's on what resources can people use, right, to learn this? If you can share resources for people, maybe it's something that they can reach out to you on LinkedIn directly, or you can give them guidance, right? I think that would be really, really great.
Okay, so I really don't have any resource for GCP, though I have a book for BigQuery that is entirely dedicated to BigQuery. So I may be able to share that. But one thing I would advise to get started is you have a Gmail account, just go to GCP, link that account to it, start things with your cloud storage, start uploading stuff. Go to Google Cloud Function, try to bring in your Python code. It's very easy, and I would have loved to demo it so that people will see how easy it is to actually deploy. Go to Google Cloud Function, try something there. The app engine, it's very easy also. I really hope, maybe in the next, if you guys don't have anybody slated for in 2 weeks' time, I'll come back to actually do this, and you guys can see how it's very easy. But I also think in Pluralsight, there are resources for GCP where you can get started. If you have some credit in Pluralsight, you can take some of the courses in Pluralsight on GCP and you can get started with it. I mean, there's a lot there. I'm not even maybe 10, 20% into the whole thing. There are a lot with Compute Engine, Kubernetes Engine, that's if you're deploying your Docker container. There are a lot. Even analytics is here these days. You can create your dashboard from this BigQuery. There is something called, you can exploit your data to Looker, or you can exploit it to Big Studio, or I think Data Studio, where you can create your dashboard exactly from here. And then you can also use your BigQuery these days to create machine learning models using SQL. I was super shocked when I saw that you can actually do machine learning models in GCP just using SQL. So it's quite vast, but don't overwhelm yourself when you start. Start with the simple tools like storage, BigQuery, Google Cloud Function, and then you can keep on expanding. But if I have any resources, if I see any resources, I'll definitely share with the group because I'm definitely joining the community. So I'll definitely share the resources with you guys.
All right. Fantastic. I know many of you have like so many more questions, but unfortunately, again, this is a recorded session and we have to consider how people are going to disseminate this subsequently. So in light of that, we have come to the end of our 16th episode of the Data Digest program. I have in the comment section Oladayo's profile. You can reach out to him on LinkedIn. Please check that out. And if you have more questions regarding this particular project, the workflow, he wrote a very beautiful article on Medium as well that you can access. And it's been a fantastic episode, I would say, to everyone that has joined. It's been really, really wonderful. And on that note, I would like to bring this episode to a close.
If you just give me 1 minute, I actually put some conclusions here because I'll just read it out in conclusion. So okay. I said for your project, when you're doing your project, maybe a personal project, set out the requirements for those projects when you start and try to achieve the requirements and identify the limitations of the approach. Then you have to keep learning. As you keep learning, you will keep on improving the project. There's never, like someone said, there's never an end to a data project. But when you keep learning, you'll see areas where you could improve on. This project, it's not done in my head because I was learning something, and then that was when I learned about Airflow. And I know that I could use Airflow for this project also, so I brought it in. I also know that you could do some kind of unit testing or an end-to-end testing on your project also. You could do that also. I learned that also, and I'll try to in the future to try to do that. So my point is just set out the requirement, achieve the requirements, keep learning, and keep iterating on your projects and keep on improving on your projects. So I really wanted to say that. Thank you so much.
Yeah, thank you so much, Oladayo. Have a wonderful, wonderful evening, everybody. Cheers.